All right, so took apart a Daikin vapor-injected VRV compressor, cut it up into a bunch of little teeny tiny pieces. This is our oil, which you can actually see some floating metal particles inside in this kind of in a distilled state here, just floating. You can even see even more at the base of our oil container. Right, kind of floating around and moving around. Now this compressor is grounded actually. And in that, things that we look at for a grounded compressor, bearing wear, which we don't really have. There's some slight discoloration due to, just standard wear and tear, as you'll see. Not the cleanest oil ports. You can see the metal shavings that are kind of around the inside reflects the same thing we saw in the actual oil itself. A lot of just tiny shards that have kind of broken off. You can see slight discoloration here towards the top, which again isn't unusual. This is the bottom of the rotor. Shaft is completely clear. Let's talk about the scroll plates. Scroll plates, there is actually some, plating that you see happening underneath. That's due to lack of lubrication, overheat on the actual compressor bearings themselves. Kind of see our divisional line there, and we'll look at this under the camera here shortly. Discoloration underneath is also a bad sign. Wear and tear to the actual scroll plates. You've got galling, which you can kind of see as I move it, and kind of slightly reflective, which we also take a look under the microscope there. But for the most part, not terrible, right? There's no noticeable wear patterns on the actual scroll plate. Remember, this is a grounded compressor, but you do see on the wall of the compressing, on the actual orbital scroll plate, that it chewed up some copper fragments. You see that embedment on the wall itself around the outside edge. That is not copper plating. Those are copper shards that have come into contact with the actual walls of the orbital scroll plate. So thick scroll plate. Let's take a look at that. Kind of the same thing, slight wear patterns, galling around the edges, discharge port fairly clean. Again, same galling pattern on the inside. You can actually find chunks missing from the oil line here, and that oil line that we're talking about is right here. Right, you see this ring around the outside edge of the fixed scroll. It goes all the way around the outside edge. That's designed to actually connect with the other oil ring that we have here on our orbital scroll plate. It's designed to be pressurized. There's a little teeny tiny port here, and this is your thrust reduction screw port that's designed to feed oil to this. Remember, this comes in through this hole here. So out here into our scroll plate section, charges this top ring. Then again, it goes back and it charges this ring here. This ring then modulates out into the open section of the suction inlet, right? There's your suction inlet right there on the right side. Then it oils and lubricates this top half here. Now, as the oil comes through here, some of it goes down here on this side port. That side port is actually designed to connect here, as you can kind of see through that little hole, on our orbital scroll plate, which goes down and kind of lubricates our old hand coupling and a few of the components that are underneath. A nice little crafty design. But when we look at this goes over to that internal to the scroll. Where does it go from here, you might ask? I will show you. It then comes over here. This is your discharge port going down to the bottom of the compressor. This is your upper bearing mount. This right here goes down, and then at 90 degrees over. When at 90 degrees over, it actually goes to that little shiny thing you see down there. That's actually a hole where the oil pools up, builds pressure under here in that bearing. That's this top bearing here, right? It comes out the top hole, comes around this, becomes in a pressurized state right here underneath the orbital scroll plate, underneath the old ham coupling, pushes it over into here, up, and then it goes through one of my favorite things to look at when we're talking about failed compressors or scroll plates, and that is the thrust reduction screw. And for some reason, I'm having a difficult time locating it. I guess someone walked off with it. So nonetheless, that's not what we're here to talk about. We're here to talk about why this is grounded and why is it still grounded after I've pulled out my rotor, my compressor scroll plates. I mean, I've disassembled this completely. why do I still only have 40 ohms inside this compressor? And so what I want to show you now is I have this on a document camera, and look at this. So at first glance, you're going to see that this is the same section that we're looking at, which is right here. I'm pointing to with my finger. In that section there, we're looking at it under a magnified amount. And you look at it and you go, oh my gosh, it's completely cracked, right? How does the winding mount, right? Because that's what this is. These are your motor windings. Here's your 3 spade connectors for your 3-phase motor connections on the electrical housing body. How does something like this crack? And so what I'm going to do now is I'm going to take a nice little inspection screwdriver here, and I am going to, right, show you that this is not a crack, but electrical burn marks across the surface. You see how when I smudge it, it comes off? What you're seeing here is the arc pattern across the outside edge of these windings. So much so that it looks like a crack or lightning in the sky, right? And that is actually the electrical discharge that took place when this compressor grounded out. And what you're going to see here is these windings that you have around the edges. If you look towards the inside of this, you're going to see right there is our failure. Right there, a burn mark between the windings that completely melted the metal connections to the point where it grounded all 3 of these phases together. There is your ground fault. It got so hot that it melted right there between the windings. And when it grounded out in such a way that it actually caused carbon to build up around the edges of the housing mount that looks like these little black cracks that you see here. This is actually carbon buildup due to electrical discharge, right? This isn't actually cracked metal. Again, this is just on the surface. Look at that. Is that not wild or what? So this compressor failed due to overheat, due to a lack of lubrication within the compressor. Not over time, but suddenly, quickly, right? Over time, we'd see more wear patterns on this. We'd see more scarring. Now, again, I'm not saying that we don't have scarring, because we do. So let's look at that. What does that scarring look like? So we're looking at now the lubrication ring that's around the outside edge. You can see the galling a lot better, a lot closer up. But also something that I want to point out to you that it's a little bit difficult to see now. But again, if I zoom in, should come a little more apparent. Okay, so you can see it now. So on this, let me just rotate it a little bit more. You can see the pitting that's taken place around this lubrication point. This is a lubrication ring that's designed to fill with oil and lubricate the scroll plates. But you can see the galling that takes place on the surface of that scroll plate as these rotations take place. And you can see, right, they move over, and as that scroll plate rotates over and it clips over that edge, you can see that it's chipped. It's chipped here, it's chipped there. You can see that there's chipping here, there's chipping there, right? This is brittlement of removing surface material, right? Galling is the process of welding and fusing metal to metal and then ripping it apart. And so that's what's taken place all around these edges here. And I'm not saying that this is the main point of failure. However, these are signs of unlubricated operation and compression within the scrolls themselves. And the same thing can be said if we look around the edge here and we see, we saw the copper plating that was on the orbital scroll plate here, right, around the edges, which means that it's sucked up a few copper shavings once in a while. But also, I mean, even look at this. We're looking at chipping. We're looking at the marks that took place on the actual orbital. Now remember, this is cast iron, right? Both of these are. And so the amount of force that it takes to scratch, scar, wear off the surface of both of these is intense, right? This isn't like a matter of me accidentally dropping my pen on something, or maybe me, accidentally scratching it with my keys. We're talking about running through a process of compression at an extremely high rate of speed that actually results in this scarring pattern that we see on the actual scroll plates themselves. Remember, this part that we're looking at here towards the center is the part that's going to not come into contact with a whole lot of things, but you can still see even there, we've got some surface damage, a few copper particles that you can see kind of that are reflective in that light. So again, grounded compressor, died suddenly. It's about 3 years old. We've got metal contamination particles floating in this distilled mess that you see of oil. On top of that, ground out, sudden event in the actual compressor motor windings themselves. Not a lot of carbon, not a lot of contaminants built up. Some particles and carbon in the base of this compressor. There are some copper particles down there that you can kind of see. Oil slump is fairly clean, not the best, but not the worst. So a combination of contamination over time, as well as unlubricated operation, high heat, results in this ground out for this particular compressor. Again, it was sudden, not extremely violent, but then again, it did die and will not start again. So compressor cleanup procedure, filter dryers, obviously pulling the charge. You can also see too, right, that this compressor over its life, right here, let's just look at this under the microscope really quick. Zoom out for you.
What's that?
You can see, right, the contamination. Look at this. I'm going to wipe it with my finger. There you go, right? Well, that didn't get there by happenstance. That doesn't come from the factory like that. That is contamination in the system. Remember, we cut this open with the compressor cutter, which means that this is like a giant can opener. There is no cross-contamination, which means that anything I find within this compressor is fair game. And so this, right, this is contamination within the compressor. Not just the consistency of the oil, but also the other metal particles that I found within this. The metal particles that are magnetized, right? This is a magnet, right? When I go like this, and I stick it to this wall, it stays. This weighs about 7 pounds. The way that's possible is because there's magnets on the inside of these inverter compressors. And again, what happens with magnets, you get metal particles that are attracted to it that build up over time, which we can clearly see here. So this is, again, vapor injected Daikin compressor, fairly clean, but still grounded. And that grounding took place because of most likely a leak of refrigerant, lack of oil circulation due to a lack of flow, high heat over time, probably ran through some high demand with no oil in it. And then again, that overheat led to, right there, compressor winding failure within the compressor.